Afternoon, each and every one of you. It gives immense pleasure to welcome you all to this 1 week FDP program. It's a good opportunity for us to interact and connect with you all. We are happy to do that. And I always believe that anything, whatever we do, there should be kind of impact on the society and then useful to us on our everyday life and also for the students. Specifically, why this FPP, specifically research? Research is a backbone of every one of us. The reason is like that as the data grow so much and then the decision making become cumbersome day by day. And as we are the faculty members of our discipline, specifically management program and whatever be the discipline, then the kind of guidance what we need to provide for that we have to be knowledgeable and also for our own research and our day-to-day publications. The right research will put us ahead of every one of us. The kind of research and then the kind of tools what we use it that make us to differentiate from one among the crowd, and then the quality of research also ensured. So with that note, I would like to welcome you all to this 1 week faculty development program on discovering statistics for effective research. I would like to underline the word effective research. Welcome you all. I wish you all happy learning. Thank you.
Thank you so much, ma'am. Now I would like to call the coordinator of this faculty development program, Dr. Vishal Shukla sir, to give the overview of this 5 days FTP program.
So, good afternoon and a warm welcome to all of you. First, I must be thankful to you for expressing the overwhelming response for this 5 days faculty development program on discovering statistics for effective research. This faculty development program is spread over a period of 5 days of 2 hours each day, has been planned meticulously so as to cater to the needs of the researchers and the academicians, irrespective of at what stage of their career they are. So we'll be starting from the very basics, and then we'll be diving deep into this statistics using some tools also, like SPSS. Today's session will be a curtain raiser and handshake with the IBM SPSS, which will be delivered by my colleague, Professor Dr. Ganesha KS. Then over the next 3 days, I'll be the resource person, and tomorrow I'll be covering on mean comparisons like t-test, ANOVA. Then on the third day, we'll be discussing on correlation. Then fourth day, regression. So for all these 3 days, I'll be a resource person. And on the last day, that is the 5th day, we'll be talking about exploratory factor analysis, principal component analysis, reliability, and all these stuff. So my sincere request to all of you that please make maximum use of this opportunity, and wherever you feel that you are stuck or you want some clarification, feel free to unmute yourself and ask. We will love to hear from you, and we'll try to resolve your queries as much as we can. So once again, I welcome you, wish you a happy learning, and have a great learning curve ahead. Thank you.
Thank you so much, Dr. Vishal Shukla sir. Now, I would like to give a brief introduction about our resource person for today's session, Dr. Ganesha KS. Dr. Ganesha KS is an assistant professor in the Department of Management Studies, Dayananda Sagar College of Engineering, Bangalore. He has 12 years of experience in the corporate, teaching, and research. He is a member of International Safety Quality Environment Management Association, UK. He has conducted training sessions on entrepreneurship awareness, digital marketing, and project management. His primary research interest is in tourist behavior, social media, sentiment analysis, human resource management, and labor studies. He has presented at multiple conferences and published articles in Scopus and other international index journals. So without taking much time, I would like to invite Dr. Ganesha KS to take over the session. Thank you.
Thank you, Karpagali madam. So, I am Dr. Ganesha KS. So, I will be handling today about the basics of statistics and what are the things you should be aware before going for the further analysis, and also we'll have a handshake with SPSS, how to import the data and how to clean and code the data into the SPSS system. So that we will be discussing. And from my session, this will be a very basic session. Most of you might be aware of the concepts, but it will be a refreshing that one and make you ready for the further analysis which you will be learning in the subsequent days. Okay, so without wasting much time, let me start with the concept. So will be okay. Is the slide visible, right? Okay. So I welcome all of you to the FDP on discovering statistics for effective research. Okay, so today we'll be discussing on theory of measurement scaling. Okay, and also one minute. Yeah. Today we'll be discussing about the theory of measurement scaling and basic assumptions of the statistical analysis, and also handshake with the SPSS and the SPSS environment. And also we'll be learning about data entry, so how to make the data entry to the SPSS file, and also cleaning and coding of the data in the SPSS environment. Okay, so the session will be very much basic. Okay, so if you have any queries in between, you can just raise your hands, or you can message in the chat box. So we'll be try to help you regarding the any queries which are coming up. Hello. Yeah. So the first is we'll be discussing about the theory of measurement scaling. So it's about all of you know we need to measure something when we are at the stage of going for the data analysis of any statistical. First, before going that, we should know what are the things we need to collect and how we have to measure. What are the things we need to measure in the particular for the data analysis. So we need to be very much cautious here in the first step, because if we collect the wrong data, we will end up in doing the analysis in a wrong way. So we need to be very cautious while regarding collecting the data. So this measurement scaling, so what we decide to do will help you and will help us a lot while deciding the analysis. Okay, so
before that, we need to start with the research process. So to decide what measurement we need to know, so we need to understand first the research process. What you require in the research data. To do any research or any analysis, we require the data. How we will go with data? Okay, so first we'll have initial observation. We may observe something, or we may have some assumption in our mind. So through that, we will come up with a research question. What we want to find out. Okay, for example, we want to find out about a particular impact or particular effect of a variable onto the dependent variable. So at that time, we need to identify what we want to identify. So the research question, the initial observation, based on our observation, based on our experience, and through the literatures. So we will go with all the literatures, whatever the previous studies done, and what problem I need to identify. Based on that, we will come up with a research question or initial observation. Then we will link that particular research question with a particular theory. So we will generate theory. We'll have a conceptual model. We will have in particular theory through the thorough literature review, and we will try to link what are the factors which might affect the particular another thing. So we'll be having a generation of theory. So from the observation, we will move to the generating the theory. So here we will have different approaches of research methodologies, and whether we are going for inductive or deductive research, so that will be decided upon the generating the theory. So we will try to come up with a particular theory. So here we will generate and build the theory. Next, we will go for generating the hypothesis. So based on the theory which is generated or the model which is generated, we will be generating the hypothesis through identifying the variables. So what are the variables which are there in the theory? Okay, what are the independent variables and dependent variables? Okay, so we will be identifying those variables and we will generate the hypothesis. So most of the time we will be going with the null hypothesis because we don't know the truth. Okay, so the research is a process where we are going to touch the truth from the assumption. So we are assuming that something, but we are checking out or testing whether that is truth or not. So then once we generate the hypothesis, we will collect the data. Okay, so we have a hypothesis. Based on that, we will come up with different types of data collection, either through primary or secondary sources of data. We might be having something like questionnaires and collect the data through that, or we might be having certain secondary sources of data. So we will collect the data now. Okay, once we generate the hypothesis, then we will have the research instruments. Through that, we will collect the data. Why we will collect the data? To test the theory. So the theory which is generated in the second step will be tested through the collected data. And here we will measure the variables. Okay, so what are the variables? Whether that is suitable for testing the particular theory. So we'll measure the length of the variables and strength of the variables, whether they are sufficient to test the theory. Once we collect the data and we are testing the theory, so once we trying to test the theories, then we will move to the analyzing the data. So that you will learn in the further session, the analysis of the data. Whichever you have collected, all the data will be analyzed through a model or through statistical analysis or through a graph, and you will be able to find out what is the outcome of the particular data, collected data. So your data will be there, which is collected through the initial observation. Through that, you will come up with a research instrument. and then you will analyze the data through fitting the model, and you are testing the theory. So whether the theory which you proposed working well or not. Okay, so this is the particular process in which a research will go on. Okay, so through the initial observation to the analysis of data, and then you are interpreting it and finding out whether the model is fit or not. Okay, so you are going to say whether the model or the theory which you are proposing can be generalized to others or other situation, or it is limited to one particular setup only. Okay, so that we will be interpreting once we analyze the data, whether our theory which we are proposing is fit for only this particular population, or it is there for all the other samples. Okay, so that is about the research process. So here we spoke more about variables. So what are those variables? Okay, so there are mainly two types of variables which are presented in any of the research. So the people look towards mainly the two variables. One is independent variable, or it can also be called as predictor variable, and second one is dependent or outcome variable. So here the independent variable is a variable which thought to be the cause of some effect. Okay, say for example, advertisement. Okay, advertisement and sales. Okay, when you take the example of advertisement and sales, so which one is the dependent and which one is the independent, that we need to find out. To check or to test the theory, advertisement affect the sales of a product. So here dependent variable is a variable which start to be affected by changes in an independent variable. Say for example, the advertisement is independent variable and sales of a product is dependent variable. So we are trying to test whether the change in advertisement or change in the number of advertisement or prime slot of the advertisement or type of the advertisement has effect on the sales of a product or not. So at this time, we will be having advertisement as an independent variable and sales of the product as dependent variable. So we will collect the data. From whom we have to collect? We have to collect the data from the people who are watching the advertisement, who watched the advertisement and who are buying the product. We can't ask someone who has not watched the advertisement. There we will be having a sampling error. So we need to ask the questions, or we need to collect the data from the individuals who are eligible to answer those particular questions in the questionnaire when we are doing the primary survey. So the independent variable, it can be many. Even the dependent variable, we can have 2, 3. So there are numbers of independent variables might be affecting a dependent variable. Okay, so that's why dependent variable is also called as an outcome variable, because we are predicting the increase in advertisement has an effect on the sales of a product or not. So that is the outcome. Sales is the outcome, advertisement is the predictor. Okay, so any queries, you can post it in the chat box. Okay, I hope all are clear till the research process and variable. These are the few basic things which are refreshing you to go further in the upcoming days. Okay, so because all the sessions are dependent on statistics, you should be very well aware what we are learning and what are the types of data we are dealing. So based on that, okay, so I hope it is clear. If you have any queries, you can put it in the chat box. So we'll move to the next step, so which is very important when we going to collect the data. So that is the levels of measurement. How do you collect the data, or what is the measurement? Say, for example, when we travel a particular distance, we have kilometer to measure. When we take a soft drink, we have the liters, or a milk, we have liter to measure the quantity. So when it comes to the research, okay, how you are going to measure a particular phenomena, okay, what you want to identify, okay, what is the outcome you are expecting, what kind of theory you are going to test, okay. Say, for example, you can't put kilometer for milk or water, okay. So there are different kind of things requires different kinds of measurement. So in the same way, in the research also, we will be able to identify the right answers or the right effects of the independent variable to the dependent variable based on the type of measurement we choose. So whether we are choosing the proper measurement scale or proper measurement method to identify the answers for the question. For example, if we want to test the effect of a particular independent advertisement on sales, if we ask whether you watch advertisement, yes or no, and then if you test that with some other variable, then you will be getting very little information. So you need to have a different approach for that. Okay, so we'll be discussing about that here in the levels of measurement. So first one is the categorical measurement scale. Okay, so it is divided into two or three distinct categories. Okay, categorical variable. Majorly, people use the nominal and ordinal two variables, two categories. Okay, so the binary variable. So first one under the categorical, because the name suggests categorical, the answers you expect from the respondents are in the categories. Okay, so you will have some predetermined categories and you will ask the particular respondents to answer in such a way about the particular categories. So under the categorical variable, first one is binary variable. So here you have only two options. Okay, so you have two variables which you are asking. Say, for example, you are asking a person dead or alive. Okay, so you can't say half dead or half alive. So you have only two options to answer, or two categories. So that is binary variable. So you have two categories where you have dead or alive. So you can't say half dead or half alive. So that is called as binary variable. Then you have nominal variable. So that is you have more than two categories. You want to ask the food habit of an individual, you will ask whether you are a vegetarian, omnivore, vegan, etc. Okay, so that is here you have more than two categories from which you can get the responses of the individuals. Okay, and then there is ordinal variable. It is also same as nominal because it has more than two categories, but it follows a logical order. Okay, so in the nominal variable, you don't need to follow any logical order. You can just ask vegetarian or omnivore or vegan or etc. Whereas when it comes to ordinal variable, you will ask in a logical order. Say, for example, you want to check whether the students, what is the performance of the student. So we'll ask fail, pass, merit or distinction. So you have categories which are mentioned in a logical order. So when you want to check the logic behind the particular effect, then you will follow the ordinal variable. When you want to collect the data about something which you also don't know the logical sequence of the particular categories, so then you will go with the nominal variable. So there is not much difference between nominal and ordinal, but only thing is the logical sequence of the categories. So that is very important in the ordinal variable, whereas in the nominal variable, there is no logical sequence. Okay.
Sir, I have a doubt, sir.
Yeah, yes, yes, yes.
Sir, suppose we have observations on Likert scale.
Mhm.
Now, and we have used, say, 4-point or 5-point Likert scale. In that case, the data will be fed on ordinal variable, right?
Yes, yes, it will be on a logical variable, a logical order. So strongly disagree. Okay.
Yeah, got it.
I would answer this. Likert
Yes, sir.
scale, madam, in its basic essence, is the ordinal scale, unless you assign weight to it or you extend this scale to 7-point or 10-point. So if you are taking 5-point scale, it will be ordinal scale.
Sir, since you mentioned specifically 5-point scale, what if I take 3-point scale? Because even that has been recommended in a few studies.
So, again, it is ordinal. You have to extend this scale to create proper intervals. Okay.
Got it.
Or you can assign weight. Let's say 1 means 10, 2 means 20.
Got
So
it. Got it.
that like that you have to treat. Or else if you are taking Likert scale, then you have to summate the entire scores to convert it into interval or ratio variable.
But you just said if you assign something like 1 is to 10 and 2 is for 20, 3 is for 30, aren't we moving towards the interval variable then?
That's what I'm saying. If you want to convert ordinal into interval, then you have to do like this.
Okay, got it. I missed that part. Thank you, sir.
Thank you, Vishal sir. So, so that is about the binary, nominal, and ordinal variable. So next one is the continuous variable. So entities will get a distinct score. So as Professor rightly said, so it is have two types. One is the interval variable, and other one is ratio variable. So interval variable has got equal intervals on the variables, which represents equal differences in the property which is being measured. Say for example, difference between 8 and 10 is equivalent to difference between 15 and 27. So when you want to have equal differences, okay, between the equal intervals, then we will have the interval scale, and then we have ratio variable, which is same as interval scale, but ratios on the scale must also make sense. So the score you get here should match the reality. So we have to be very careful while using the ratios scale, or when you are converting a particular ordinal or a categorical variable into the ratio variable, because here whatever the score, say for example, you are checking the anxiety of a particular person, you are measuring the anxiety through a scale. So the total score which you get should be matched to the reality. So whether you are checking whether a person is anxiety or not through a questionnaire, and when the ratio when you measure it should match. Okay, both the persons are having a different thing. Otherwise, the ratio variable will be handling those particular data through the ratio variable will be difficult for you to proceed, because when you don't match the reality, there will be a problem of statistical error, or the type 1 or type 2 error you will be end up getting because of the wrong choice of respondents. So it has to be properly collected data. So then only you can move to the ratio variable. Otherwise, interval scale variable, it has the particular equal difference between the interval variables. So these are the particular level of measurements. So any doubts here?
No, sir. It is clear.
So next, always we will be end up getting error in statistics. Okay, we have to deal with lot of errors, because as we are human beings, so we will be having certain misconceptions, certain wrong assumptions, or wrong way of collecting data. So this is also existed in the measurement, so that they are called as measurement error. So what is this? So the difference between the numbers we use to represent the thing we are measuring and the actual value of the thing we are measuring. So that is the value we would get if we could measure it directly. For example, we have a particular number. We want to represent something. So we are collecting the data of, you can take the example of same anxiety scale. Okay. So we are measuring the anxiety of an individual, but the actual value of thing we are measuring is something different. Okay. So that will cause the measurement error. So it might be due to faulty instrument. Okay. So in reality, something is different, but what we have measured is not representing to the reality. So actual value of the thing we are measuring is different. Say for example, simple example of 1 kg of a particular vegetable. So if there is an error in the machine, so you will end up getting less quantity because there is a error. So the difference between those numbers, we represent the thing we are measuring, what we are measuring, and what is the actual value. So the difference between the actual and what we are measuring, so that is called as measurement error. And it is very important to understand the measurement error also, because if you don't do the particular analysis with the without identifying the measurement error, so you will be adding that error element to the analysis. So thereby you might be missing out saying the particular thing in a right way. So it's always better to avoid errors in the measurement. For example, you will go back to the last slide. So you have a variable, you want to check how many people saying or how many people died through the COVID-19. So you need to ask how many people died or alive after getting COVID. So you are asking simple question. Okay. So whether put the number of people who are died or alive. So instead of that, if you ask a wrong statement, or if you are measuring through a wrong particular scale, so then error will happen in the measurement. So always we have to be very much cautious. So we have to we will go back to the research process. Okay, what is our research question? Okay, so what is our research question? Okay, so and then how that particular research question is related to the particular variable. Okay, so whether the research question is related to the identified variable and the data you collected is proper to the research question which we have selected, whether all things are in the sync. So that we need to identify, then only we can avoid the measurement error. However, there might be small errors, but the error should not deviate the actual things. Okay, say for example, if there is a here, okay, here our assumptions are there. Okay, so here we have our assumptions. Drawing is visible, yeah, and here there is the populations. Okay, so there is a truth here. Okay, so there is a truth which we are going to find out through our assumptions. So our assumptions may go here, or our assumptions may go here. So when that happens, there will be measurement error. So because we are finding out the truth here. Okay, so the point of the truth is here, and there we will be doing the wrong measurement or wrong estimation about the what is called as truth. Okay, so then we will be having certain problem because we are not exactly identifying what is the truth. So that's why it's very important to know what we are identifying, what we exactly want to measure. Okay, say for example, if you want to check which social media is people watch us more. Okay, you need to ask, or you need to check with a proper scale. When you want to measure the effect of social media on some particular aspect or education of the children or addiction of the children. So then you can ask a different kind of measurement. So you need to be clear in your thought, and there should not be any stigma in the mind relating to choosing which measurement scale I need to use for which particular data. So it all depends on your research question, what you want to identify. Okay, so what is your outcome expected? So based on that, you will choose the measurement scale. So always there might be error, but our assumption should meet to the truth. Okay, whatever we assume, that should meet to the truth, then only the things will go in a proper way. Otherwise, we may end up giving a faulty outcome or faulty results to the statistical analysis or the research which we are carrying out, and which someday will have bad implication on us also, because we are going away from the theory or the truth. Okay, so research is all about finding out the truth. Okay, what is the truth existed and whether we are reaching to the truth or not. So that is the main aim of the any research. So here, uh, after this particular measurement error, okay, so we will be moving on to the basic. Any doubts in the measurement error? If you have any, if you want any clarifications.
No, sir.
Thanks, sir.
Fine, fine. So next is basic assumptions of statistical analysis. So in the upcoming next 4 days, you will be doing a lot of analysis, okay, regarding the statistics. So what are those basic assumptions? What we should keep in mind while we do the statistical analysis? So it's not a simple thing, and it's a simple thing, statistical analysis. Okay, when we know what we have to do, it's a simple thing. Okay, when we think we don't know, or when we don't know what is the process or what we want to do, so then the statistical analysis will take a hit on our head, and it will look like difficult because we don't know what are the assumptions of statistical analysis. So what are the things we should look before carrying out to the analysis of a particular data? So we have huge data with us, but we should first know what we should do with that particular data, whether that data is able to have this or satisfy these assumptions of the statistics. Okay, so first assumption of any statistical analysis is to check the normality. Okay, so we need to find out whether the data is normally distributed or not. Okay, or at least whether the data is symmetric. So normality is always checked with the data which we have collected should come inside the bell-shaped curve. Okay, so then we can say data is normal, or it has to be at least symmetric in nature. Then we can go with certain parametric tests, which in the next session, Dr. Vishal will go in depth. I won't go in depth into this concept because while teaching the testing of normality, so he'll be going in depth with the concept. So here, the main basic thing is, basic assumption is data have a normal distribution. Okay, so he will tell what to do if the data is not normal or not symmetry. So then you have some other thing to do with respect to the statistical analysis. So basic assumption, data has to be normal. Data should not be skewed. So what will happen when we have this bell-shaped curve, and when we have data like this, most of us have experienced. So these are called as skewed data. Okay, so the data is at the either positive side or at the negative side of the curve. So that is either positively skewed or negatively skewed data, but data is not normally distributed. I'm not saying it is wrong, but there are some particular things which you can't do with this skewed data, because skewed data means there might be chances that all the respondents are believing in one particular aspect, or respondents are not happy to fill out the questionnaires, not happy to respond properly, so everything is going in one side. So it might be through the errors of data collection, but skewness might be there because of the errors in data collection, or it might be happen due to uh, a thing which is having a positive or one kind of impact. So then you need to find out whether that particular measurement scale suitable for this particular type of research question. Okay, so when you have a research question and it says about everything is going well, so you found out through your observation everything goes well, so then you need to devise different kind of question to have the data which is normal. But you can't help once you collect the data, that's fine. It's of the, it might be the errors of the respondent, or it might be the reality which is happening, so that we need to clear it out. Okay, so we have to be very much clear what is happening there. Okay, so next we'll also check about homogeneity of the variances. So here we are going to find out whether the data from multiple groups have the same variance. So the variance which is happening between the variables. Okay, so data collected from multiple groups. For example, you are collecting data from say Bangalore, Chennai, Delhi, Kolkata, Mumbai. So there are different groups of people and different multiple groups which are there in different cities. You are collecting data from everyone, and all those groups variance should be same. So then that is called as homogeneity. Okay, so this is also very much important when it comes to the uh, fit fit of the model. Okay, whether you can generalize the statement or not, it depends on the homogeneity or heterogeneity of the variances. Okay, that you will be studying, I think, in the fourth day of the session, how these things will be affecting your models. Okay, so then we need to check, or we need to check the assumption of linearity. So whether data have a linear relationship, or data whether they have non-linear relationship. Okay, so when you check that linearity, so you are going to find out whether the data suits for certain particular assumptions of the statistics or not. Okay, so whether any relationship exists between the independent, dependent, or between independent variables. Okay, so there are several techniques and tools which we will be discussing to check the linearity, and also very important, independence of the data. So that is test of independence, that is whether the data are independent. So all the data which you have collected, whether they are independent of each other with respect to the independent variable or dependent variable, or whether there are any correlation or autocorrelation, there are relationship between the variables. So almost all of most commonly used statistical test or rely on the adherence to some distribution function. Either you will check the normality or homogeneity or linearity or independence. So based on that, you will go for the particular analysis. Okay, so the tests which are based on the particular assumptions, if they satisfy, they are called as parametric test. So sometimes when one of the key assumption of such a test, see what will happen when you have uh, data which is skewed. Okay, so data looks like this. Okay, everything are here, and you also feel that this is the real responses. There is no bias in the respondents. Okay, so all data are here. So there is no normality in the data, but it is reality. So then how to carry out the statistical analysis? Because if the data is normal, as I said, we will go with parametric test. So what will happen when we don't have the normal data, when we have skewed data or when data are not normal? So then we will go with, when the particular assumption is violated, then we will move with a non-parametric test. So there is nothing wrong. Okay, if we intentionally do any errors, so the results will also show the same error. For example, the effect of a drug on patient health. Okay, so everywhere it is positive. When we have an error in data collection, it might show a negative effect. So that we need to be very cautious. Okay, so the same things will be checked in the medical also, and social sciences also, and scientific analysis also. So you have to be very much careful at the time of collection of data or framing of the research question and research instruments. If we have a particular wrong research instrument or wrong research question, which is not going in a proper way, so then we will be end up doing a wrong analysis. So when we don't have the normal data, or when the assumptions are not met, we will be going with non-parametric test. So such tests don't rely on specific probability distribution function. So they won't check whether the data is probably distributed or not. Okay, so but you will be doing some statistical analysis because of that. Okay, when you have the data which is not normal, so it's very difficult to convince others. Okay, when they hear that your data is not normal. Okay, so it will be a very difficult step to take on to the non-parametric test, but sometimes it works to tell you the reality of the analysis. Okay, so any queries in the assumptions? Okay, so we'll move to the next step. So that is, what is the purpose of statistical analysis? Okay, so yes, there is a query. All four assumptions should be satisfied to be a parametric test. See, it depends on the distributions. Okay, so what test we are going to carry out? Okay, so depends on the statistical analysis which we are carrying out. Okay, so we need to check whether the normality or homogeneity, linearity or independence. Okay, so when we choose the parametric test, yes, for different parametric tests, we need to check all the four things. Then only we can go with a particular parametric test. If we have some errors, okay, at least there should be a symmetry in the normality. Okay, so then we can go with a parametric test. Okay, so we have different measures which we will learn in the further sessions. Okay, yeah. And if you okay, no, different test assumes different assumptions. Okay, when we are carrying out a particular regression, we will have certain assumptions. Okay, mainly if we are going with a parametric test. Okay, so we will be checking about the normality. If we are going with say other kind of test. Okay, so each of the assumptions depends on the different types of tests. So each test will have different assumptions. Okay, so is it clear? Yeah. So next is, what is the purpose of doing the statistical analysis. Why we have to do statistical analysis? Why can't we simply present the data and leave it? No? Why? What is the reason behind the doing of or carrying out the statistical analysis? So when we conduct a study and measure the dependent variable, we are left with a set of numbers. So we have certain set of numbers which are left it out. So those numbers may not be same. Okay. So that is, there is variability in the numbers. So as we already discussed, the variability can be usually result of multiple variables. So this might be include the differences or errors or confounds, but maybe include an effect on the independent variable. So what are those things? Okay. So why statistical analysis helps to find out what are those errors, what are those individual differences, and what are those extraneous variables. Okay. So you might be having, say for example, you collected the data, so it might look like this. Okay. So everything are coming in one particular checkbox. So suddenly one variable will be out here. Okay. So there might be an outlier which is affecting more. Okay. So you need to be very much cautious. Why statistical analysis? That is to measure the variables and also to check the variability in those multiple variables which are existed in the data. So challenge is to extract the number of meaningful summary of behavior which is observed and meaningful conclusion towards the influence of a experimental treatment or independent variable on the dependent variable, that is participant behavior. So how do you do, or how do you find out the particular effect of independent variable to the dependent variable? So that is through the statistical analysis. So statistics provide us with an objective approach to do the particular test of effect of one on the individual variable on the dependent variable. Okay. So statistics has got some rules and some assumptions as we discussed earlier, and we will be moving with the particular. Okay. So we'll be moving with particular result of the observation. So how to get the results? That is through the statistical analysis, which will help us to get the outcome which are expected, or we may get the unexpected outcomes. So this is the purpose of carrying out the statistical analysis. So we'll take some 10 minutes break, and then we'll be back with the SPSS environment. Okay. If you have any queries, you can put it in the chat box. Welcome back. Welcome back to the session. Yeah. Is it audible? Voice? Yeah. So there is a query. Yeah, there is a query. Just rename your device's name. One more request. Okay. Because I can't get to know who is that person. Okay. So somebody mentioned Dell. Okay. So kindly forgive me. I didn't got your name. So there is a question. What is the difference between interval scale and ratio scale? Okay. So the difference is very little difference. Both looks similar, but only thing is the interval scale. Okay. So and ratio scales. So they came from the ability to dip below zero. So interval scale, they hold no true zero, and they can represent like values which are below zero also. For example, when we are checking the temperature, okay, we can say minus 10 degrees Celsius also. So that is an interval scale, whereas ratio scales, they will always go above zero. For example, height or the weight of the individual, we can't say minus or negative weightage. Okay. So that is the small difference between the ratio scale and the interval scale. So in the interval scale, you can have the measures going negative also. Okay. Whereas in the ratio scales, it will be always start from 0. Okay, so that is the little bit difference. So when you measure the particular item, and if it's only the positive thing, start from 0 and it ends on some number, okay, then it is ratio. When you have negative measurements, okay, so when you have negative values of the measurements, then that will be included in the interval scale. So there is a very small differences, okay, so it's not much difference, but usually we will not recognize what is the ratio or what is interval when we don't go or when we don't play with the data fully, okay. Usually we will think everything as interval scale only, but there is a small difference, that is when you go in the negative value, so below 0, so that will be used in the interval scale, and when you start from 0 and end with the any numbers, so they are called as the ratio scale, okay. So with that we will be starting now. I think yeah, I hope all of you install the SPSS trial version, the link which we have shared. Okay, so we will be now moving with the handshake with SPSS and the SPSS environment of how to enter the data or clean the data and code the data in the SPSS. Okay, so if you have installed the SPSS software, I hope all of you have installed the trial version. So just open up the SPSS software. Okay, so I will just share my SPSS screen. Yeah. Yeah. So the SPSS screen will look like this. Okay, so the SPSS output, it will look like something like this. Okay, so the main screen, it is generally looks like an Excel spreadsheet. Okay, so it has the same categories and you can enter the data here. Okay, so I hope you have received the mail regarding the data sets and also the trial version installation for the SPSS. Um, so if you have installed, open your SPSS software and you will see a screen something like this. Okay, uh, and from the downloaded data sets, okay, so you keep all the data sets ready. So from tomorrow onwards, Professor Vishal will be doing the extensive analysis of different tests, and Dr. KG Hemalata will also be taking you towards the exploratory factor analysis and other reliability test and principal component analysis. So today we will be just knowing how to enter the data into the SPSS. So I hope all of you are opening the SPSS screen. So there are several options in the SPSS environment. Okay, so first and foremost, very important thing is the file option. Okay, where you can import or add the data. Okay, so there are two ways to enter the data into SPSS. One is through opening the database which is already stored in your particular system, or sometimes you can go to variable view. Okay, and you can define the variables and you can come here and for example I am entering say for example age and gender. Age and gender. Okay, so automatically the names will be coming here. Okay, so this is one way, that is manually you can feed the data into the SPSS environment. So directly you have a question here. So from that you can enter the data here also directly. And one more thing is you can upload the file. So you can open the data and you can import. Okay, so you can import the data. So here I will try with a particular data set. Okay, so there's a data set called as SAQ.SAV. So all of you have received. So you can open that data sets. So here you have files of type. Say for example, you have a particular Excel sheet which is collected from a Google form. So when you download it from the Google form, so it will be downloaded in CSV format. So save once again after opening that CSV file to XLS, and you can upload those particular data also. So as we have data set which is saved in the SPSS format, so you have the SAV file that also you can upload. So there are different types of data sets available, so you can upload them directly. Okay, so when you upload this, the data will be loaded into the SPSS environment. Okay, so there are different questions. Okay, say for example, okay, so this is the particular questionnaire which is developed by Dr. Vishal. Okay, statistical anxiety questionnaire. So there are Likert scale 1 to 5, and there are some questions to measure the anxiety of students about the statistics. Okay, so these questions has been added as a particular coded data. Okay, already data is coded here in this particular data set. So this is one of the way to export or import the data to the SPSS environment. Okay, so in SPSS environment we have the edit option, so you can undo the thing. Okay, and you can come back with the recently done the changes, and we have data option. Okay, so we can define the variables and you can identify the duplicate cases, you can identify unusual cases. Okay, you can compare different data sets which can be done while doing the certain measurements or certain tests. And then you have transform. Okay, so once you, for example, upload the data, okay, so I will upload another sample data set. Okay, so when you upload the data, so sometimes it will come like this. Okay, so previously which you saw is already coded data. Okay, so this is the SAV file. Okay, statistical anxiety questionnaire. So that is already coded. Whereas sometimes you have data set like this, okay, which is not coded and some of the data are missing. So how to deal with this particular thing? Okay, so there is a IDs, birthday, okay, rank, gender, okay, athlete, height, weight, smoking, sprint. So there are different variables. Okay, so now you have to come for important function that is called as transform. So here you have an option of coding the data, and also you have an option of computing the different variables into one factor. Okay, so first we will check with the coding the data. So here the data are not coded properly. Okay, so sometimes you have to clean the data before coding the data. You have to clean. So which data you don't require. So for example, for my analysis I don't require IDs, so I will delete the IDs. I wanted to check the age, but the birthday has been mentioned. So you have to transform that. Who are the people born on 3rd January 91, 96? Okay, so there are different people, and here you can see one data is missing. Okay, so these are the challenges, practical challenges sometimes you will face when you get the questionnaires which are filled by the particular individuals. So for that, you have the data which is coded. Okay, so now data which is not coded. Now we have to code this into a particular numeric data. So here we have different variations in the data. So we need to make sure that we are using it to analyze them properly. So what we will do, we will go to transform. Okay, all of you just follow. If you have opened the SPSS environment, okay, just follow. So upload the both the files, import and practice together. So you will be able to do. So go to transform tab. So in the transform, go to automatic recode. So there is one way, one another way. So you have the questionnaire, for example. Okay, so what we will do, the traditional method. See, there is a question, statistics makes me cry. So it's already coded. 1, strongly disagree is 1, strongly disagree is 2, neutral is 3, agree is 4, and strongly agree is 5. So we will have coding at the questionnaire only. So it's better to have that one, okay, in one way if you are collecting physically. Okay, if you are collecting the data physically, if not through Google Forms, sometimes you will be having to double entry. So one is you can code at the questionnaire also, because whatever you do, you have to understand whether that is also happening or not. So it has to be incongruent with the questionnaire also. So you have to be very much cautious. Say for example, here we are going to transform this data into a coded data. One is you can select this particular variable, say it is birthday. So we have to give a new name. Okay, so I will just say new birthday. So it will code the data. Okay, then once you enter the new name, remember, click add new name. So if you don't click add new name, what will happen? I will just show the example. So I have mentioned rank, okay, and I will put it as RNK. Okay, then I will select gender. So suddenly what happened here is that name has not been added. So always whenever you enter the new name, click add new name. So then only you will be able to do. So then gender. So I will put GNDR, add new name. Okay, so like this there are variety of options. Say for example, I will choose height and weight also. Okay, so you can select all the things together, okay, and recode it, code the data together after naming. Okay, weight. Okay, so okay, well, put weights. Okay, so there are the names. So we understood to name the variable to a new name. Okay, so once we name it, now we have to go for coding. There are practically two problems here. Okay, so one is you can choose treat blank string values as user missing. So this you can click it so that it will calculate the missing values also. And sometimes people will click use same recording scheme for all variables. So I will just show what will happen with that, and then I will show what will happen if you don't click this use the same recording scheme. scheme for all variables and also treat blank. So now I have clicked both and I have run the automatic recode. So in the output, it will come. Okay. So there is a warning. Okay. And when you go back to the output, okay. So here you have to get the birthday. See, I have selected same variables. Okay. So there is rank, gender, and height. I have clicked treat user values as missing. So it is giving the missing values are also left blank. Okay. So it will sometimes affect our analysis. Okay. So in the same way, when we go to transform automatic record, so because there are many things. Okay. So I will leave birthday. We have age anyways. Okay. So what we will do? So there is rank, gender, height, and weight, even birthday as such. Okay. New birthday. So what we will do? Okay. So when you have already existed, it will not show. Okay. So I will uncheck this, use the same recording scheme for all variables. So what it will come? So there will not be any continuity between the different variables. Okay. So what will happen when you click that one? When you don't check the use same recording scheme. Okay. So there will be, I will just delete this. Okay. Old data. So now will be automatically recording, and I have unchecked use the same recording. So what will happen to the output is, okay, so it will have different recording scheme for different variables. Okay, so it will not be similar. So you have a different kind of coding scheme. And when you go to the again, okay, what will happen when you don't checkbox any one of this? Okay, so then when you run the analysis, okay, let me delete this particular thing, then run. So once you have done, and if you have to run again, so you have to delete the entire the variables, and then here there is a shortcut. Okay, yes, somebody has raised the hand.
Sir,
Yeah.
May I speak? So may I speak? Am I audible? So may I speak? Am I audible?
Yes,
Yes.
madam. Yes, madam.
So when we do this recoding thing, we have just renamed it to a new variable, but we have not given any recoding scheme, any new formula, so that it can convert
Yes.
the date of birth into age. So can you
Yes.
demonstrate
That
it
also.
fully, so that from
Yeah.
first point to end point we can do it?
Yes.
And indeed, sir, even in duplicate entries, you showed us the option, but can you, our humble
Yeah,
request is to just demonstrate one entry so that we can see how duplicate entries are being done.
Sure. I will show. I will just showing the basics. Okay. Next, I will be moving to that one only.
Yeah,
Okay.
thanks.
Okay. So when you go to the automatic record, and when you don't checkbox both of the things, okay. So what will happen? Okay, when you don't check the treat blank string values as user missing. So what will happen is, okay, so there will be certain entries which are blank, so that also got filled differently. Okay, so now coming back to the converting the date of birth into the, you are converting date of birth into the years or ages. Okay, so you have to convert from date of birth. So what we have data here is, okay, so there is birthdays. Okay, we have birth dates of the students, for example. Okay, So now we will go to transform. Okay, so there are different options here. Okay, so to convert different variables into different options. Okay, so now there are as we said earlier, this is just coding the data from the particular data which you have collected from say data which is collected to a particular number. So now to convert the age into computing the age from year. Okay, so one is you can go with the formula. Okay, so there is a date and time wizard. Okay, so you have a particular variable, okay, containing a date and time, or calculate with the dates and times. Okay, you have time or date. Okay, so now we will select which one is required. So you can enter the sample values here. And also one more thing is you can recode the data into different or same variables. Okay, so here you will change it to the new variable. Okay, so value you have to change from old value to the new value. Okay, so that is one option. So there is if option, which one you have to include. Okay, so there is different options to convert different kinds of data. Okay, so from converting year to the age. Okay, so you can also go with the particular phenomena. Okay, so just like I'll just show. So you need to go with the syntax. Okay, I will just come back to that. Okay, so there is a syntax programming. You have to run the script and change the particular thing into the date variable, converting the string or data variable. Okay, so next is in the transforming. Okay, so I will just come back to the particular converting date into the age. Okay, so then yes, I will just demonstrate. Okay, I will just explain the tabs one time and then I will come back to the age thing. Okay, I will just come back to the age. So once the transformation is done, once you code, you can go to the analyze option where you will get the different types of analysis. Okay, which you will be doing in the next class, next sessions. Okay, then there are direct marketing techniques where you can build the model. Okay, and also you have graphs which you can build, and there are different utilities and add-ons and windows. Okay, so now coming back to the age. So how to, so first thing is, so whether the date which is mentioned is the real date variable. Okay, so when we come to the variable view, okay, so we have to check whether it is real date variable. Yes, it has mentioned as type is date. Okay, so type as mentioned as date in the date, month and year format. Okay, so now we have understood that it is in the date variable. Now what we will do, so we have to choose a comparison age. So at age at what in point of time we are doing. Okay, so whether we are checking for today's or at the time of collected the data. So we need to be aware, say for example today. Okay, so but most of the time we will be measuring at the time of data collection. Say today we have collected the data, so all the data collection happened today. So now we have to compute the age with the known completion date. Okay, so you need to go with a, okay, syntax. Okay, you need to have the particular if. Okay, um, so you have one more column. Okay, so I will just insert a variable. Okay, so now that is called as our calculated date. So that is today's date, the collected date. So now we will write today's date like 18, okay, 7/20/22. Okay, so we have written the today's date 18 minute 7/20/22. I'll just define the variable. It's in the numeric, so you have to change it to the date. Okay, otherwise it will not take. Okay, so you have converted its type to numeric to date view. So now you will enter, say for example, 18/7/2022. Okay, so you will copy the same to all the other variables. Okay, so there are some missing data. Okay, so there is a huge number of data set. So for everything, so I am selecting all the dates and I am copying the today's date as a base. Okay, so now we need to identify what is the average number of date. Okay, so hmm, 1 minute. Yes. Okay, okay. We'll come to that one. Okay. So later we will be coming with respect to the missing data. So first we are checking with the data variable. Okay. So now we have this one, C date and birthday. Okay. It's a simple script we have to run. Okay. Sorry. So we have to just check whether we can uh, code that particular or calculate. Okay, so for the missing values you can always go with replace missing values. So what is that missing values required for that particular thing and what is the new variable? Okay, so that we will come to later. Okay, so now we have birthday and C date. Okay, so these are the two variables, so we need to compare and find out the age. Okay, so what is the difference between this and this? Okay, it's a simple mathematical calculation which we will be performing. Okay, so we'll go to transform. Okay, so we'll be record into different variable. Okay, say for example age. One minute. Okay, so now we have two dates. Okay, go to transform. Okay, date and time wizard. Okay, so there you choose calculate the date and times. Okay, with date and times. So you have two dates now. Okay, so now calculate the number of time units between the two dates. Okay, I hope you are following. First, go to transform. There, go to date and time wizard. Calculate with dates and times. Then calculate the number of times between 2 days, or you can add or subtract duration from a date. So add month to an age or add a time variable to a date. So that also you can do. So there are two options. So now we are checking between 2 days because we have added 2 days date also, because usually we will be doing with respect to the date of data collection. Say today is the date of data collection. Then next, okay. So now you have option current date and time is also there. We will just choose the birthday as date 1 and current date C date as date 2. So unit in what we want. Okay. For example, if you want in the years, we can choose months, units. So we will choose years. Okay. So now after choosing the years, so there are options truncate to integer, round to integer, or retain fractional part. So that means you can move to the whole figure, say 21, 22, like that. Or you can, if you can retain the fraction part also. That's left to the individual. So I will choose truncate to integer. Okay. So now I will click next. Okay. So what is the result variable? Okay. So you have to give the name for the result variable, say age. Age is the result variable. So that is the age in years. Okay. Create the variable now or paste the syntax. Okay. So what we want to do. Okay. I will click create the variable now and finish. Okay. So now if we go back to the last column, okay, we will find age. So that is we have clicked the difference between. Actually, we did a small mistake here. So that is so date 1 is today's minus birthday. So when we do that one, we will get the ages in years. Okay, that's why we got a negative value because we have selected the current age as second variable. So now we got the age as 3126. So if you see the date of birth, okay, 1991 3rd January to the 18th July 2022. So the age is 31 years. Okay, 31 years is the age of the respondent. Okay, so what will happen? Okay, here you can use this tool to quickly come back to the previous analysis. So what will happen? For example, I will just show with dates and time. Okay, subtracting. So here birthday. Okay, so I will retain fractional part. So here what will happen? Age in fraction. Okay, variable name is age in years fraction. Okay, so now when we finish, what we will get is we will get the exact date 31.54, 26.54. So it is there in the fractions. Okay, so exact age of the individual, which is there in the fractions. So either we can use the ages or age fraction. Most of the time you use the round or truncated integer only. Okay, so I hope this conversion of birthday into age is fine. Okay, are the steps clear? I need to repeat.
Sir, we'll practice today and then let you know tomorrow, sir, if there's any doubt.
Sure, sure. I will just repeat the step. Okay. Go to transform. So with the data set, okay, go to transform date and time wizard. Okay. So first is going to transform. Second one is date and time wizard. There you have variety of options. Okay. But choose calculate with dates and times. Click on next. Okay. So you have here also two options: add or subtract or a duration from a date, or calculate the number of time units between two dates. Okay, so you can have both option. Click next. Okay, uh, see, first I have chosen C date as minus date. So when we do that, we will get the value in negative. So when we choose the date 1 as current date and the birthday as the date 2, so when the difference between two, when we truncate it to integer, or you can round to integer or retain fractional part. Okay, you have three options. Okay, so then click on next, name the variable. Okay, age in years new. Okay, then click on finish. So you will get the age column. Okay, so that is the basic coding of the particular age. So you have the year. So the people have mentioned the birth date in their responses. You are converting that into the age. So now there are different options. So we learned about the coding of the data, and we learned about converting the particular birth year into the age. Okay, so okay, so there are different options, okay, which you will be learning in the next session onwards. So Professor Dr. Vishal Shukla will be handling those sessions, so that is checking of the normality and how to deal with the missing values also. So when the missing values comes in your analysis, so what are the steps to cover? So tomorrow you'll be learning about that one, and you will check the normality of the data and then go for parametric or non-parametric test and how to go ahead with the other things. Okay, so as of today, this is just a introduction and how to enter the data and how to clean the data. So that is from birth date to the particular age. So in the same way, you can recode different variables into different forms. Yes, you can clean the data in Excel and you can then import also. So that's why I have shown the one more data set. When you clean the data set, it will look like this. Okay, it's already coded and it has uploaded. Okay, so you can do both the ways, but there might be certain things which you may not be doing in Excel, so that you can do it in the it is better to import in the Excel file rather than CSV file, because certain options or certain responses will go diverted. So it's better to import through Excel file rather than CSV. CSV will have comma separated values. So sometimes the data get mishandled if you're not properly importing the data from the CSV file. So it's advisable to go with Excel file.
Bhaiya,
Yes. Okay, yeah, normal Excel format. So normal your responses format. So the variable names in the top with the particular responses. Okay, so you don't need a predetermined. So only thing is even in the Excel it look like this. When you import from the Excel, so the first tab which you have mentioned, you can name the variables names, and same thing will be imported here. When you have a particular data which is not named or which is not named in the tab, you can name it here in the SPSS also. So that's not an issue. So tomorrow you'll be learning about the other aspects. Okay. So any queries? Okay. So if you have queries, you try this particular at home, okay, today, and tomorrow at the start of the session, if you get any problem, so you can raise the queries, okay. So we will try to sort it out, and thank you for the responses and the questions asked in the deliberations, okay. So if you have any queries, you can share back tomorrow's session also. Even in tomorrow's session, you can ask the particular queries. Thank you.
Thank you, Dr. Ganesha sir, for delivering a wonderful session. So I hope all the participants have got idea about this theory of measurement scaling and basic assumptions of statistical analysis. And also I've got an opportunity, all of you would have got an opportunity to learn this SPSS at the basic details. Thank you, Dr. Ganesha sir. So participants will meet again in the tomorrow's session. The meeting link will be shared and you all can join by 3 p.m. tomorrow. Thank you all. Have a good day.
Thank you, ma'am. Thank you, sir.